This is lesson 3.1, where we will investigate properties of triangles. Now on GSP, we will have done an investigation involving the centroids of triangles and see how they interact with each other. Before we move on, we want to know a couple of terms, and those terms are the word concurrent. Concurrent, which means meeting at a single point. Meeting at a single point. Now we can see on the triangle there are already a few places where two lines meet at a single point. They're called the vertices. But when we go on drawing other lines in our triangle, such as medians and centroids, then we'll find out that there will be more lines coming out of a single point. We'll draw that in a second. The next word that we have is centroid. Centroid. This is the point where the three medians of a triangle intersect. The point where the three medians of a triangle intersect. Well, in order to draw that, we're going to have to review what our medians are. Remember, a median in a triangle goes from any point, any vertex, to the midpoint of the opposite side. So just a rough estimate here, I'm not measuring or calculating, but let's say this dot is the midpoint of BC, then the median from A will attach through the midpoint of BC. The median of B, get down here to the midpoint of AC. And the median of C would go across there to the midpoint of AB. So these line segments are equal. These two line segments are equal to each other. And again, if we drew the median from C, we would have two equivalent line segments along AB as well. So there's two definitions to help get us started with our properties of triangles. Concurrent, meeting at a single point, and centroid, where the point where the three medians of a triangle intersect. And you're going to discover that right there, the third line, you can already see that third median is going to head right through that point and bisect the line segment AB. This unit, we're going to spend a lot of time using our critical thinking skills to identify properties and characteristics of geometric figures. So in this example, we have a triangle. We have an isosceles triangle, and we're talking about the median of an isosceles triangle. The question is, what are the properties of the median from the vertex between the equal sides of an isosceles triangle? And it sounds like we have a lot going on there, but it's really quite straightforward. The first thing we want to do is notice that we are working with an isosceles triangle. Well, let's go ahead and draw any old isosceles triangle. We remember that an isosceles triangle has equal sides, two equal sides. And there we go. It's not perfect, but we will call these two sides equal, and we will label our triangle A, B, C. So there we have isosceles triangle ABC. And we want to learn about the properties of the median. Well, there's three medians in every triangle. There's a median from A, a median from C, and a median from B. So which one do we want? We want the median from the vertex between the equal sides. I have three vertices, so A is the vertex that falls between the equal sides. So what we're talking about here is the median from A down to BC. And we want to know about the properties of that median. So what is true about that median? So I've drawn my median here, and I'm going to label this point D so that we have something to talk about. The median then is AD. Now what can we say is true about this median? We know that a right bisector of a line segment includes all the points that are equidistant from the endpoints of the line segment. So what that means is if we have the points BC, we have the line segment BC, then that makes B an endpoint and C an endpoint. Now the right bisector of BC will involve all of the points that are equidistant from C and from B. Well, let's explain that a little bit further. I already know that A is equidistant from B and from C because the lengths of these sides are equal. But I also know that D is the midpoint of BC because the median always goes from a vertex to a midpoint. So I know that the length between BD and the length between DC are equal. Well, now I have 2 points. Point D is equidistant from BC and point A is equidistant from BC. And if we remember what we know about lines, that means every other point on this line is, and if I continued the line, it would continue to be true, is equidistant from the point B and the point C, which makes AD, by definition, the right bisector of BC. So we didn't know that the median was going to be a right bisector before we started, but because we know BA equals CA, making A equidistant from B and C, and the point D is equidistant from the point C and the point B, then we know AD is indeed a right bisector, which means it is perpendicular to BC. So what are the properties of the median from the vertex between the equal sides of an isosceles triangle? Well, it coincides with the altitude of the triangle. Right? The altitude is the height of the triangle going from A straight down, making a right angle with the line segment below it. So this median from A is the exact same line. It coincides. It's the same line as the altitude of the triangle. Well, what else do we know? Look at this angle up here, angle A. What's happened to it? It's been bisected. That means it's been cut perfectly in half. How do I know that? Well, what we have here is actually 2 triangles. We have the triangle ADC and we have the triangle ADB, and we can see that they share 2 sides. They share a side in common here, they share a side in common here, and of course they share AD, which must be the same length for both triangles. And so what we have here is actually congruent triangles. So since triangle ACD and triangle ABC are congruent, the median AD bisects the angle A. And there are 2 properties of the median from the vertex between the equal sides of an isosceles triangle. The median coincides with the altitude of the triangle, so it's the same line as the height of the triangle, the altitude. And since ACD and ABC are congruent triangles, the median AD bisects angle A. These 2 angles must be equivalent because these 2 angles are equivalent, and the angle C and the angle B are also equivalent in an isosceles triangle. So there you have it. We've used our critical thinking skills. We've analyzed the median of this isosceles triangle, and this is a good example for what you are going to be doing throughout this unit. Homework for lesson 3.1 comes from the worksheet that I've handed out to you. That is worksheet 3.1, it says on the top, and we will be doing numbers 1 through 4, 5b, 6, 8, 9, and 11. On 11, you're going to want to construct it on GSP, Geometer Sketchpad, and then just write down some notes of what you've discovered. So there you go.